Welcome to our final video on water. This is a pretty cool slide taken from one of the satellites orbiting the world. We can focus here on the United States, and we can actually see just how much of the world is covered in water. And this water out here probably useless from a turf grass perspective because it's so full of salt, and then small amounts of fresh water around my hometown, the Mitten, Michigan. The east coast here, quite green, probably adequate moisture, and then we can go out west and see how very brown that is and how short on water we are. So we're going to talk about some of these water issues, some of the way man is affecting water, and how you as future turfgrass managers can help conserve and protect the planet for the rest of your following generations. So water conservation. So this is what I like to think of when you think of good, healthy water, a beautiful mountain stream. This is probably what we don't like to think of when we think of water conservation. This is what can happen if a turf manager improperly applies fertilizer, particularly phosphorus, to a pond. We can get these horrible algal blooms that can kill all the fish and really make that water useless for irrigation and for human consumption. Here's a local golf course. I'm not going to tell you which one, but you can see that process starting. There's quite a bit of algae, and pond maintenance is one of the things that is very, very important. And I think from just looking at a golf course pond, I can usually tell from the irrigation pond the quality of the greens, because good golf course water management health happens at the pond. So the next series of slides is going to talk about the hydrological cycle, water, and how it moves about the world. 97% of water is in the oceans. So 97% of the total water on the planet is useless without large inputs of money for golf courses and plants, or in most plants. Some vocabulary words. You really need to understand evaporation, which is water moving from the soil to the air. Transpiration, water moving from the soil to the air through plants. Precipitation, which is rain, snow, or any other way water falls down to earth. Runoff is one of the main concerns we're worried about, is any water moving laterally across soil surface, which quickly goes to ponds, creeks, streams. And then the one that we're probably most interested in for turf grass is percolation. That's the water that gets down through the soil. So that's the one that we can manage. That's one we really want to focus on as we talk about this hydrological cycle. Here's a nice diagram that explains it. We've got our precipitation, so our rain is coming down. Some of it will run off the steeper slopes. The faster that goes into ponds or basins, so this would be a freshwater basin here. Some infiltration or percolation, which goes down through the soil, becomes available for plants, and then eventually to groundwater through a millions of year process. Water is evaporated from the oceans. We have evapotranspiration from the plants, and we have evaporation from the soil. So this cycle of water going around is something you should really understand. And there are lots of different places where man can affect that cycle. And we'll talk about that in the next few slides. One way man can dramatically change this cycle is impervious surfaces. For every meter of concrete, every meter of roof, cement, asphalt, roofing, all of those put water together and force them to move faster to the oceans. This sort of bridge embankment doesn't provide any sponge, any storage of water. So water rapidly moves from inland to the oceans. And a lot of the reason that our hurricanes are such a big problem now, more than they used to be, is because there's more and more meters of hard surface where this water quickly goes into this grate, quickly comes out into this river and floods the coastal areas of North Carolina and the world. So we're not storing the water properly to be able to get its full benefit. A simple definition of runoff: snow melt or rain that can't be absorbed into the soil. And we can see there are some solutions to this problem. Here's a big mall parking lot. In the outer areas, sometimes you don't need hardscape. Sometimes you can have plants or turf as a parking surface, and perhaps we need to think about this. And one thing that angered me is the Homer lot at the college. When they were building that, we did a proposal to put that in this sort of surface, a surface you can drive on but that's grass and park on. And it was rejected by the city commissioners because they told us that nobody had ever done that before. So education is a huge part of this, overcoming ignorance and overcoming just because we've done it this way for so long, maybe this way's better. And being able to convince government of that is one of the things that I think you as turf managers and you as environmentalists need to be able to do in the future. So here's our updated world. Instead of grass on this hill, we've got factories. So we decrease the infiltration because of this hardscape. We increase the runoff, increase the pollution, just simple facts that are ignored because of development and urban sprawl. So I guess it's just something you really need to think of and understand. So this slide's going to hit a little closer to home for the class on water sources for agriculture. We've got our natural rainfall, surface water, those ponds and lakes in Michigan or any sort of stream, and then groundwater. And I want you to draw a firm line in your mind between these two. And oftentimes we don't understand that well, and I don't think municipalities understand that well either. Groundwater is true, it's a renewable resource, but it's a very slowly renewable resource. There's 8,000 to 100,000 trillion gallons of water in the ground in our aquifers, but that's renewed very slowly. So this should be our first choice. Ponds, streams for irrigation. When we go to wells, we're getting into groundwater that's a resource and a valuable resource. And probably for golf courses should be built on areas where there's adequate streams and ponds without going for groundwater. Another source for golf courses is sometimes city water. City water comes from either of these sources. It depends. Pinehurst gets the majority of its water from rainfall, but there are some wells. Some homeowners think that if they have a well, it's free water, and it kind of is, but it's taking away from the whole supply. So there will be regulations in the future about wells. And golf courses need to protect themselves against the need for using sources that can be shut off in the future. So important in your mind to understand these different sources of water. Some things society can do to help conserve water: eat less meat, 2,500 gallons of water to produce 1 pound of beef, a few more vegetables, a little less meat will probably be healthier for everybody and conserve some water. By using the proper amounts of water, we can increase yield and preserve water resources. And then the most important, really, let's put a star here, reducing runoff. Reducing erosion, which will help decrease flooding, which will decrease pollution. So keep your water on your golf course. Some things we can do on the golf course. Effluent water is coming. Using water when it comes out of the sewage treatment plant makes sense. It requires a little more work. There are things in that water that you need to know what those things are. They vary from municipality to municipality. Salt management is something you need to understand and pay attention to. One of the biggest problems with effluent is simple gravity. Most sewer systems are designed to flow down to the sewer plant. The sewer plant is usually at the lowest spot in the county, so to get that water back up to the golf course is expensive. Jack said that's what pumps are invented for, but pumps use energy, so that's one of the hindrances right now, is the expense to get that effluent, but we'll be seeing it. Using proper turf management. And then the recycling or wash pad. I'm going to talk about a pretty good example of reusing the wash pad water. Or reusing it, not necessarily reusing it for washing, but we can also reuse it for irrigation after we're done with that. And that's probably a pretty good use of it and less stinky. So here's a wash pad that I think is designed pretty well. This is the width of a bobcat. You spray, all the machines are sprayed off here so that the waste goes down into this wash pit. Gravity allows this water to go down, and this water is used to irrigate the driving range, and then a bobcat can come in and get all that organic matter out and compost it. So this is at Pinehurst number 8. There's Jeff Hill, the superintendent here, and I thought this was a pretty good design of making a nasty job as easy as possible. There's some handwork in there. That is something for the new young guy to have to be able to do to prove his mettle. It can get stinky, as you all know, in the summer, but it's important to wash those machines off, and it's important to reuse that material, the grass clippings for compost and the water for irrigation. Some courses will even move their wash pad, wash pads in the rough, which serves to irrigate the rough, and then the clippings will be out there for recycling. So that's probably a good way, is to pre-wash a lot of your equipment out in a movable wash pad before you bring it into the shop, and finally clean it at the wash pad. But getting as little organic material, bringing it in on the equipment, is also a pretty good practice. Here's a close-up of the back side of that. There's a metal filter screen where all the organic matter gets caught, and you probably have to get in there with the shovel and move that out, but it's a pretty effective wash basin in an area that's a pretty sensitive environmental area. Runoff. Again, I'm not going to say where this is, but if you have open soil areas, oftentimes soil is going to follow gravity, particularly with the help of water, and come out. So who knows what's in there, but I really don't like that coming into my irrigation pond. I want to know what's in that water, where it's coming from, and why whoever's upstream is allowing that much soil to get into the water, because that's not healthy. Another thing not healthy, I've never figured out why smoking cigarettes allows you to litter. So I don't know what we can do about that, but it's probably a nasty problem. And I know I don't like picking up other people's cigarette butts, so pick up your own cigarette butts, please. A little bit of water use efficiency. You don't want your irrigation to ever put down enough water that it runs off. You want all the water to go in through percolation, and even all the water that's properly applied, 90 to 90% of that is put back into the air. And that's not a bad thing. The plant needs to move moisture from the roots to the shoots for lots of reasons we've talked about in previous parts of this water plant lecture. Plant water and soil. So stop the runoff. Use low enough flow heads that you don't have water puddling or moving across the surface. You want maximum percolation, meaning you might have to irrigate one section and then go on to another and then come back, and understand evapotranspiration. So better efficiency will limit runoff and then catch as much rain as possible. Here's a system that was designed to do that, and grass does a good job. Grass is going to stop, keep water on the surface. It's going to filter nutrients out, and then hopefully all this water that's coming out of this pond is going into another pond where we're going to stop it, store it, and be able to use it for later. So connecting your ponds and being able to pump from one to the other and use them is also a good turf grass practice. Here's a picture of an old golf course that has since been redone, but this head down here in the bunker is probably not effective. It's spraying into this bank, all the water's coming back into this bunker, so it's just creating work. So having proper irrigation installation is imperative on the golf course. So capturing water in the soil should be our main focus. We can do that through soil texture. Sands are going to allow water to infiltrate much faster. Good soil structure, secondary soil structure, is going to create macropores that allow water to go in. Organic matter addition to clay soils or sand soils is going to help moisture stay. It's going to act like a sponge. Decreasing compaction through aerification and proper turfgrass practices. Decreasing hard pans, again, proper irrigation. And then reducing our slopes, smoother slopes. Sloping to ponds that store water will also help. Strip cropping out west is something that's used where we don't plant entire areas so water can build up. Contour tillage, smoothing out slopes, so that's a slope thing. And then riparian buffers, and I'm going to show you some pictures of riparian buffers. And what that is providing plants along the edges of rivers and streams in order to slow the flow of those rivers and streams so we don't get as much flooding downstream. Some turfgrass methods of increasing water intake, proper aerification. We've got our guys over here smiling, running the aerification machine. That's going to increase water percolation, water moving into the soil. Subsoiling, a deeper aerification that'll break through any hard pans you have. Mulching, using crop residue around areas where water moves quickly to slow that down, or in beds to slow water's movement through those areas. This should be increased percolation through coarse soils, and then wetting agents. When we have dry areas, we can get out there with our soaps and aerify and use those. And so here's a grading machine. That's another way you can bust through a hydrophobic layer and allow water to get into the soil in a better manner. Wind increases water loss. There's not a lot we can do about it. If you're in a windy area, you're going to need to irrigate and be aware of that. Wind can also mess with irrigation efficiency, causing the heads to not go where they were designed to go. An increased root system is going to help you draw from a bigger pool of soil, which will always be better for any plant. Syringing to cool the plant. Anti-transference, where you spray plastic on the plants to close the stomates. I don't recommend this for golf course use. It's probably has its use when you're moving trees. And then one thing we don't think about often, but very important for water use, is weeds. Weeds can oftentimes use a lot more water than the proper turf grass, particularly a drought-tolerant or drought-resistant cultivar or species. So good weed control is going to help with good water use. Proper fertilization, particularly nitrogen and phosphorus, are going to stimulate good roots. Remember, no excessive nitrogen. Excessive nitrogen is going to do the opposite. Excessive nitrogen is going to cause excessive top growth and decreased root growth. Using drought-tolerant varieties and cultivars, and drought-resistant varieties and cultivars and species. So the proper grass for the proper place. And then xeriscape. We see some down at the landscape gardening, some plants that require less water as we move into the future might be the solution in some situations. I think it's a big problem to be putting high-using landscape ornamentals or annuals, particularly way out on the golf course, maybe around the halfway house, definitely around the clubhouse, but let's stick the golf course to grasses and grasses that manage water or help us manage water better. There have been a lot of water quality issues. They tend to come up when there's a water shortage. We do need good water. In North Carolina, one of the big problems has been excessive nitrogen in the water system. Some of the rivers, the nitrogen content is rising very quickly. It has a little bit to do with hog production. It has a little bit to do with population growth, wastewater treatment plants, spills, sewage spills are all going to be things that increase nitrogen. Factories. Some factories produce chemicals that are put in the water. So there's a point source polluter would be someone that has an exit pipe into the river. So those are easy to monitor. We can treat those. We've decreased those quite a bit. Non-point source polluters would be agriculture. Golf course doesn't have actually, a golf course does have point source places where water comes out of a green and would go into the pond, but most would be small enough that they're distributed across a body of water in a small way. So agriculture is usually considered non-point source, and it's more difficult to control. Any fertilizers that get into the water are going to increase salt problems, and salt in your water is going to require more water, and it's going to create an osmotic potential gradient across the plant that is difficult to overcome. And we can see if we're putting down water that has salt in it, the irrigated area might even look worse than the non-irrigated area. This is in Hawaii, where they had a salt-contaminated pond, and you can see the dramatic color difference from the salt side and the non-salt side. Fertilizer spills or animal urine, same thing. We've got nitrogen that will burn in the center. Then we see greener grass around the edges. It's getting the proper amount, and then normal outside of that. So fertilizers, proper fertilizers, don't make the mortal nitrogen sin that we talked about in earlier parts of this course. So, number one way to reduce pollution, reduce runoff, reduce erosion. We don't want soil in that runoff, so those two go hand in hand. Reduce fertilizer loss. Use proper amounts of fertilizer. Make sure it's percolated in and not run off. Reduce your pesticide usage. Same thing. Store all your chemicals in a properly certified agricultural storage facility, properly labeled for the fire department so they know if there's a fire in there. Usually a metal building, preferably kept away from where you keep your people and your lunch and those type of things on the golf course environment. And retain your water. Don't let any water get off your golf course. Keep it, use it, reuse it. Generally water coming onto the golf course is dirtier than water going off, but really we don't want, in this modern world, any water leaving. We want to store it. We want to have ponds and adequate storage facilities for water. One of the best examples in the world of proper water use, storage, conservation is Pinehurst number 8. This pond here in front of Jack's teeing off on the 14th hole at Pinehurst number 8. In the 1920s, if you flush your toilet in Pinehurst, this is where it went. This was the storage pit for that. So the golf course has taken that over. It's maintained this pond in a healthy way. We've seen wildlife come back to it. It's a great success story for an Audubon golf course. You can see that the pond is filled with water in times of excess. In the summer, when the moisture goes lower, it's more like a wetland with lots of birds, lots of juncus, lots of food for birds, animal forage area, beavers and muskrat in this area that was once a toxic waste place. One of the other issues going on is changing riparian buffers. This was an old stream that had been dug straight on the NC State campus. They've come in and done a huge restoration project on that. They have removed a lot of the surrounding areas, and they've made that stream meander. So trying to slow that down, trying to build buffers of natural plants that will stop moisture, stop fertilizer runoff from all these parking lots, and allow the river, the stream, to move slowly, and the silt and any dirt or organic matter from the parking lots to settle out so it doesn't so quickly get to the ocean. And that's our cycle. So we want to keep the moisture here, because once it's out here, it's useless. And properly done, we can keep the planet spinning and turning for generations to come. Thanks for listening, and I'll talk to you in class on Friday.